This is FOA lecture number 44 in our series on fiber optics. And this particular lecture is the fourth one, which will cover MPO array-style connectors. As we discussed in the prior three lectures, the MPO connector is an array connector with a 12-fiber array and alignment pins and a key. And these all produce complexity when it comes to establishing the polarity or the connections of the fibers inside the connectors. MPO connectors have four options. They have alignment pins, and some of the connectors will have pins, and some of them will have no pins or holes, so that they can mate to a connector with pins. In addition, each connector has a key, and the key may be up or down. So there's actually four combinations of pins, no pins, key up, and key down in the way they can align. Besides pins and no pins and key up, key down, we've got the arrangement of the fibers in the 12-fiber array. What we've shown here is fibers 1 to 12 using the standard fiber color codes, starting with blue in position 1 and ending in aqua position 12. That's just where we're going to start. There are three different types of MPO to MPO cables, types A, B, and C. And we'll look at them more closely so you can see how they are configured. Type A cables are straight through. You can see the blue fiber is mapped from position 1 in one connector to position 1 in the second connector. And the aqua fiber goes from position 12 to position 12. So this is easy to understand. The fibers are always in the same place in each connector. A type B cable reverses the fibers. So the blue fiber in position 1 on one end becomes position 12 on the other connector, and the aqua fiber in position 12 becomes position 1. Why do you need a cable like this? Well, if you're doing parallel optics for 40 gig, that's the way you map the fibers for transmit to receive. Here's an example. In 40 gig parallel optics for multimode fiber, fiber 1 is used for transmit, and the equivalent receiver is in position 12. 2 maps to 11, 3 maps to 10, 4 maps to 9. And that's the way they are mated. Thus, if we flip all the fibers, reverse them completely, transmitters will be talking to receivers. I guess that makes sense, doesn't it? A type C cable is a very different type of cable. It does reversed pairs. So the pair fibers, blue in 1 and orange in position 2, are reversed. So in the far end connector, the orange fiber is position 1 and the blue fiber is position 2. Likewise, for each sequential pair of fibers down to rose and aqua in the end. What's the use of a cable like this? If you're breaking the cable out to pairs of duplex connectors or simplex connectors, and you need to connect them up in order to mate the transmitters and receivers, you're going to have to do a pairwise reversal. What's questionable is whether you should do that by using a Type-C cable or whether you should do the reversal in the breakouts, or what's typically in prefabricated cable systems, modules on either end. Because if you have a Type-C cable, you can't easily go back and convert it to something like using it for parallel optics. So it may not be the best solution. It may be better to use modules. Besides the 3 types of cables, there are 2 types of mating adapters. The Type A adapter mates 2 connectors key up to key down. That means that the fiber in position 1 on one connector is connected to the fiber in position 1 on the second connector, and likewise all the way down to the fiber on 12 is connected to 12. This means that this provides a connection straight through, and whatever connection you have on one side continues on the other. A Type B adapter mates the connectors key up to key up, and that reverses the positions of the fiber. So your blue fiber on one connector coming in on position 1 is mated to position 12, the aqua fiber, on the second connector. And as you can see, this does exactly the same thing as a Type B cable. It reverses all 12 fibers and can be used in a similar fashion to reverse all the connections. There can be even more complexity if you have 2 or more rows of fibers. There are cables using this 2-row connector that are mapped straight through like a Type A single-row connector, some that reverse fibers in each rows like a Type B cable, and some that reverse fibers and flip the rows. And yes, there's even a version that reverses fibers pairwise. It's enough to drive you crazy. If you intend to use these multi-row connectors, you need to work with your cable supplier to carefully document what you get, because you'll need that information for troubleshooting, later changes, and replacement of components in the future. And there's one more level of complexity. That's the angled MPO, primarily used for single mode. Because of the angle ferrule, it can only be mated with a Type A mating adapter, key up to key down. That means any fiber manipulation that must be done has to be done in the cables, unless you've used the Panduit Pan MPO, which allows changing the key on the connector. As you can see, MPO polarity can be extremely confusing. These are just some of our recommendations. Know what you want to connect. Know how many connections and cables you will have, which means you have to know how much loss your network can tolerate, because MPO connectors typically have higher loss than single fiber connectors. Design with the fewest types of components. Keep records of the types of every component and mark them on the components for moves, adds, changes, and replacements to make sure you don't get confused. Getting one component out of position in a cable plant can cause you untold grief trying to determine what's actually going on. If you haven't seen them already, be sure to see the 3 earlier lectures in the FOA YouTube series talking about prefabricated cable systems and MPO connectors. We're the Fiber Optic Association, the International Professional Society of Fiber Optics. For more information, including a lot of this information on these crazy MPO connectors, go to the FOA website, foa.org.